the chance given to be a moderator for this keynote session 2. Good afternoon, everyone, and then good afternoon all the committee members. Good afternoon, Dr. Jimmy, Dr. Benny. Yes. So this second keynote session will be delivered by Professor Chuan-Kai from the Department of Information Management at National Taiwan University of Science and Technology. So first of all, I would like to also give our thanks to Professor Yang for accepting our invitation to share your knowledge and your research with us in InCITE 2021. So before we begin, I will briefly introduce Professor Yang. Professor Chuan-Kai is a professor in the Department of Information Management at National Taiwan University of Science and Technology, Taiwan. So Professor Yang also the director of the Computer Graphics and Multimedia Laboratory in Taiwan Tech or NTUSD, and his research interests include computer graphics, multimedia systems, scientific visualizations, algorithms, and computational geometry. Now, without further ado, let's welcome Professor Yang. Yes.
Still mute. Okay, yeah, it's okay.
Okay.
Okay, thank you, ladies and gentlemen. Thank you for Alex's introduction. I'm so glad to be invited as one of the keynote speakers. So I will be sharing one of my researches, which is on doing some photo taking. Okay, so it's like taking a group photo and without asking the help from others. So I think Alex will help me to do the presentation, and I will be answering questions afterwards. Thank you.
So thank you, Professor Yang. Now I will start the presentation video of Professor Yang. So can everyone see my other screens?
Yeah, I can see it.
Okay, so let me start.
Johan, have you shared the audio?
Sorry?
You need to share the audio when you share your screen.
So
yeah, we cannot hear the sound.
Yeah.
Cannot hear the sound?
Yeah, I think you need to stop the video, the screen sharing, and then share again. And there's an option when you share. There's an option to include the computer audio at the bottom of the options. You need to stop screen sharing. Okay, and then share screen again, and there's an option to include audio.
Okay, share sound. Okay. Oh, okay, thank you, Dr. Jimmy.
That's all right.
Okay, now I will play again.
Ladies and gentlemen, I'm Dr. Chuan-Kai. I'm very glad to be invited as a keynote speaker, and this is the title for my presentation. It's called A Multi-Person Selfie System via Augmented Reality. Okay, so I'm from Computer Graphics and the Multimedia Laboratory, and it's in the Department of Information Management at National Taiwan University of Science and Technology. Okay, so this is actually a paper that's recently published in a journal. Okay, so I'm going to briefly describe the research here. Okay, so this is really about photo taking. I think everybody knows that nowadays photo taking is extremely easy. Okay, however, the issue is for taking a group photo. Okay, so let's say if we go to some scenic place and we want to take a group photo. So there are two cases. First, if there are too many people around, okay, so then we are in trouble because many times the views may be blocked by people. However, if there is like no other people around, we are also in trouble, because if you want to take a group photo, then there is no one to help. Okay, so you may think that we can use a selfie stick to address this problem. However, everybody knows that we have this distortion problem, that the one closer to the camera will get larger, and also we due to this the length of selfie stick is limited, so actually the distance is also limited. That means sometimes it's very difficult to get the whole body into the fit into the picture. Okay, so you may think that probably we can use a like Bluetooth enabled tripod. Okay, so then use remote control. Okay, however, it's still a problem. So because we need to find a stable place to put the camera, and also we don't have like a much control of the photo composition process. By photo composition means that we want to determine how this people look like in the group photo, and also with respect to the background. So in this regard, the most related work that we can find is this one, PICME, okay, Interactive Visual Guidance for Taking Requested Photo Composition, published in 2019's InCITE conference. So the thing is like this. So we have a lady to ask a gentleman to take a photo for her, and also she may have some idea like how the photo should be taken. Okay, so basically the process is really about how to align that the photo taking process that we have in mind with the real photo taking process. Okay, to solve this, actually this paper proposes many approaches. So for example, here we have a picture-in-picture idea. Okay, so we have a picture and we try to match what we see in the phone. Okay, and also we can make use of some features like the edges and try to match them, or perform some edge overlay to have a better alignment. Okay, so in our system, actually what we are trying to do is take a group photo. Actually, you can see that in the previous paper, it still cannot help, right? Because if we are talking about taking a group photo, then when there's no people around, how can we take a group photo? Okay, so we propose to use 3 steps to take a group photo. So the first one is that we assume like in this example, the gentleman is taking a picture of a lady first. So once this photo is done, then we can try to switch their positions. Okay, so now it becomes the lady to take the picture of the gentleman, and through the help of our system, through the help of augmented reality, this lady will get to see that her image itself is displayed together, okay, with the gentleman, so that we can the lady can guess to determine how to compose the group photo in a better manner. Okay, so the issue is really about how to align 2 photo taking processes. Okay, so that we don't have too much artifact, and also is about photo composition. How do we combine 2 people together? Okay, so there's some mathematics involved. So basically, the problem is how do we align 2 photo taking processes, or how do we align 2 photo taking coordinate systems? So there is some rotations or translations. I mean, this kind of transforms are involved. So I'll skip the math. So if you are interested, you can try to look it up in the paper. Okay, so I think the main contribution of our paper is that we propose an operation A tool, okay, to help us. So basically, if this aid tool or some sort of interface shows the status like this, that means these two photo taking processes are perfectly aligned. And in cases like this, that basically means that we should try to move far away from the person, and if we see a green circle, that we should move closer to the person. Okay, so if the circle is to the left, that means we should try to move the second photo taking process a little bit to the right. And also we have some other cues, like to indicate if we should rotate the cameras or not. Okay, so using this various cues, various colors, we can help align the photo taking processes. So this is like a more realistic example. So first, the lady is taking a picture of a gentleman. Okay, so this is on the lower right. This is the real case, what is happened, and then this is what we see from the camera. And as you can see here, if the two photo taking process is perfect, okay, so that means this this gentleman is now moving away from that photo taking spot, and then the lady is about to take over the photo taking process. However, if the alignments do not go well, then we will see this various cues to indicate we should try to adjust the alignment. Okay, so when the status goes like this, that means it's like more properly aligned. Okay, so this is like in the real case, the lady steps in. Okay, so now it's the gentleman's turn to take the photo of the lady. Okay, so through the help of this system, the gentleman actually can also see himself appeared in the image. Okay, so once we have determined that this alignment goes in a perfect manner, we can press this photo taking button to take the final photo, to generate the final result. I think you should pay attention to the sort of the shadows near the shoes of the gentleman. Okay, so as you can see here, actually there is no shadow. Okay, so basically that means in this process, at this stage, actually we sort of extract the human part. Okay, from it, it's like we extract the human as a foreground. Okay, and then use it for the photo composition process. And once this alignment is determined, we can try to generate a final photo. So now you can see that actually we can see some shadows in the final composited image. Okay, so as you will see later on, we actually try to make use of two real photos and try to combine them through a seam or through a cut. Okay, so that what we really do is to make use of some real photos and combine them together. Okay, so that we will generate a realistic photo. Okay, so this is like a more detailed process. So we have two photo taking process, so there must be some overlap. So once they are aligned well, so we can try to find a seam, okay, to combine these two images together. Okay, so there is like a more detailed process, like the system flow. So actually later I will show you a video to give a better illustration about how the system works. And this is the architecture involved. So we are using an iPhone. Okay, so it's with the iOS, and then we have this various libraries that we can make use and to like make this work possible. And this is the involved AR technique. Okay, so it's called AR Kit because this is like the AR libraries available on the iOS. And also we need to stitch two images together. So this is the detailed image stitching flow. Okay, so there are also other issues, like if the two foregrounds, they overlap with each other, how are we going to deal with that? And also, what if there are some shadows? Okay, so for the first issue, so let's take a look at this example. So actually in this case, when these two foreground people are like close or even overlap with each other, then we can see that there is a problem, because when they overlap like this, it's very difficult to find a seam. Okay, so because of that, then we try to actually try to find a seam along this sort of the shape boundary, but you can see that the shape boundary is kind of with some artifacts. Okay, so we actually try to use some Gaussian blurring, try to smooth the edges before the composition. For shadows, actually this is what we can see if we don't consider the shadows, and this is to consider the shadows. So basically this means that when we try to find a seam to composite two images, we also need to like avoid the shadows, so so with that we can sort of include the shadows during the compositing. So to verify that our work can really help generate like realistic images, we try to conduct some user study. So we generate 10 images. Actually, some of them are realistic images and some of them are fake ones. That means they are actually generated by using our system. And we have asked 20 people to rank these 10 photos in terms of realness. And it turns out that 3 out of this 5, okay, 3 out of 5 mostly voted photos are generated by our system. So this means that many of them will think, they think that our system generated images are realistic ones. And actually we have also conducted a preference survey, and it turns out that our system is preferred by almost 60% of the people, where selfie stick is preferred by less than 10% of the people. And this is like the cell phone that we use. And this is like some system statistics, like the memory and time used. I think in most cases the involved memory is reasonable. And for timing, actually you can see that most of the time is spent on exposure compensation. So if you want to have higher quality, you can spend more time on doing that. Otherwise, in general, the whole system will take less than 2 seconds to finish the composition. Okay, so now you can see that there are some more images generated. So for this one, actually the same person appeared twice, and the same person actually appears 3 times. I think you can notice that there are very complicated shadows and the reflections, and our system can still handle them well. And more images. Okay, so there are still some limitations, like if the 2 images are not aligned well, we do see some artifacts, or if 2 people are like too close to each other, then we can see there are some blurry parts. Okay, so to conclude that we have designed an app that can take a group photo, group selfie, without the need of asking help from others, and avoids the potential distortion of using a selfie stick. Okay, the current limitations are The first one is still hard to deal with the complicated overlapping cases, and also if two photo taking processes are poorly aligned, and still the result may not be that good. So in the future, probably we can try to make use of the depth ability that available on most like more modern phones or new phones. And also for the alignment, we can try to probably make use of the sensors available to make the alignment process more intuitive. Okay, so I think, okay, so for your information, this paper is also published in a Computer Graphics Forum, one of the very good journals. So I'm going to show you a video, okay, to explain more about the process.
Via augmented reality. We propose a technique based on modifying existing augmented reality technology to support the selfie of multiple persons without suffering the common distortion drawback of using a selfie stick. First, let us watch the process of taking a group photo using our system. As shown in the video, we assume that the two users of the A and user B. In the beginning, user A took a photo of user B, and then they exchanged their location. When user B is to take a picture of user A, user B will not only see user A but also himself, being overlaid on the screen of his camera. Such a juxtaposition could make the composition of two persons much easier, especially when there are no other persons that can help. We use the Operation Aid tool to help adjust the position of the camera for better results. When user B presses the shutter again, the final result photo will be produced. Through the above process, we will get the following results. We now describe the system flow of this work. According to the previous demo, we use the camera to take pictures twice, and both pictures are sent for object detection. And the bounding boxes for both detected persons will be used later on. The detected bounding box for the first person, which is denoted as bounding box 1, is sent to GrabCut, an AR kit for further processing. After the bounding box 1 was sent to GrabCut model, which extracts the human shape as an image texture, AR kit could generate a human-shaped virtual marker to be overlaid with the display. The Operation Aid tool helps the user adjust the position and angle of the camera. Both detected bounding boxes and the taken pictures are sent for the stitching module, where some tasks including image warping and graph cut will be performed to achieve the final resulting group photo. The Operation Aid tool is designed to help align two photos taking configuration. The position, radius, and color of the circle near the center of the tool, called the origin hereafter, are used to indicate how far away from our cell phone deviates from the ideal location. The three horizontal bars below are used to show the angular difference for the x-axis, y-axis, and z-axis. And note that the color of the bounding box for the first person or bounding box 1 will turn from red to green to indicate it's a good timing to take the second photo, thus achieving a group photo with satisfiable quality. We can also use the system to generate some interesting photos. In this example, we produced multiple illusions of the person being photographed through multiple shots. Next, we will show a series of photos generated by the system. above is the entire content of the demo. Thank you for watching.
Okay, so this is all that I want to share with you. Thank you. So are there any questions?
So do you have any questions for Professor Yang?
Yeah, thank you for watching this. So yeah, any questions that I can answer?
Yes, Dr. Simi.
Yes, thank you, Dr. Yang. That's a very, very interesting application that you have there.
Thank you.
Very interesting. Just one question. I was wondering if it's possible that the background is slightly changing. So for example, imagine if we have we want to take a picture with background is like a crowd, say in the market. Is that possible? Because it changes, the background is changing.
Yeah, it's very, very interesting. Yeah, because honestly speaking, when we want to align two photo taking processes, we need to match some features.
Mm-hmm.
Okay, so I think as long as we have found enough matching features, then actually this process can go on. Okay, so it's possible, of course, if the background is too dynamic, it changes a lot, then we may have a problem. Yeah, but I think probably in the future we can think about how to address this. For example, we can have something that is more stable, and then we try to enforce that kind of stable thing to be used as a matching cue. Otherwise, if the background is too dynamic, I think it will be more challenging to align two photo taking process.
So in current application, how many subjects can the application detect as the what's called the one that is considered as the subject, not the background?
Okay, so I think right now we actually just pay attention to persons. Okay, so actually I think they can be multiple persons. So currently we try to make use of object detection, particularly human detections, because I think we are mostly interested in taking group photo of persons. Yeah, so if this app is going to take photos of animals, probably we need to modify that object detection engine a little bit. Yeah, so currently I think you can see from the demo, we can handle actually more than 2 persons. We can have multiple persons. Yeah.
That's awesome. Thank you.
Thank you.
Thank you, Professor Yang. So in case that we have a question for Professor Yang, then the audience can directly contact Professor Yang through his email, or maybe can also refer to his published paper.
Yes.
Since the work has been published in the journal, in Computer Graphic Forum, right? Yes. Yes. So that's it. So thank you, Professor Yang, for sharing an insightful research. Let me summarize a few things. In this work, Professor Yang and your group from the Computer Graphic and Multimedia Laboratory design an app, develop an app, a working app actually, that help the users to take a group selfie without the need to use the selfie stick or even asking help from other people. So the app itself first detect the subject, the model, to become the base to be used in the augmented reality. So to guide for the positioning for the second person and the third person if we have multiple person in that picture, right? Yeah, and the most important thing is that the development of the operational aid tools that will help to give some direction in which directions that the photo will looks good in the end, right? The final results, and also the angle, the distance between the models, the shader itself, before all the images are combined into one final picture. That's very interesting. Yes. So yeah, thank you, Professor Yang. And now, before we conclude this keynote session 2, we will have